Welcome back. So today I am going to be explaining to you today's assignment. It's going to be a book reading and then also a worksheet that you're going to fill out in ClassKick. We will take today and then tomorrow's virtual day to finish that up. So first thing, hopefully you have made it into Google Classroom. You can click on this Earth Resources right here, or you can go into classwork, and then it will be under our Natural Resources tab. You can click on the link and you will type in your name. While that loads, there will also be another link here to pull up the book reading. So you can go ahead and pull up that book reading. And then ClassKick is taking a while to load. But what those worksheets are going to look like is this right here. So you're going to read the book and follow along with this worksheet and fill in these different boxes using ClassKick and the text box and the toolbar that they provide. So this is what it's going to look like. I'm going to come up here and I'm going to put my name, because we always want to have our name on our work. Otherwise, I won't be able to grade it. So first thing that I always do when I open these is I kind of take a look at what I need to do. So we're looking at natural resources. It looks like I'm going to have to define natural resources, give examples of natural resources, and then what we use natural resources for. So it looks like we're going to give 4 examples and then show 4 things that we use natural resources for. Next, we're going to come down here and it looks like we're looking at non-renewable resources. So we're going to give 3 examples of those fossil fuels, 3 examples of minerals, and then tell what they're used for. Okay. Next, I'm going to go to the next page, and I'm going to look over here, and we're going to examine the 3 types of renewable resources. So our 3 types are air, land, and water, and more specifically, we're looking at oxygen, carbon dioxide, fertile soil, wildlife ecosystems, fresh water, and oceans. And we're going to give uses for each of those. All of these are located in the reading. Next, we're going to identify 3 inexhaustible resources. So inexhaustible means non-renewable or renewable pretty much, right? So inexhaustible means that we will always have enough of it. We will always have enough to continue to use it. So we're looking at those renewable resources. So 3 inexhaustible resources that can be used by power plants to provide electricity used in homes. Next, we are going to contrast 3 types of natural resources. So we're going to look at the non-renewable, renewable, and inexhaustible. And we're going to analyze it. So identify an example of a non-renewable resource, a renewable resource, and an inexhaustible resource in the room you're in right now. Last page, we are going to describe, we're going to look at what type of resource and then describe how it's used. So for solar energy, we're going to describe how it's used. Wind energy or wind farms. Hydroelectric power. What does hydro mean? Hydro means water. And then we're looking at electric, so electricity. Tidal power. Geothermal energy, so geo, earth, right? Thermal is our heat. Biomass, bio means living, right? So we're looking at living things. Next, we're going to classify renewable energy resources by their advantages. So advantages is non-polluting, and you're going to match up what renewable energy source that goes to. Available in the United States, relatively inexpensive, produces little pollution, and reduces organic material in landfills. So you're going to take all of these and match them up to a renewable resource. So first thing I would do is read through all of those, just kind of see what we're going to learn about. And then I would pull up my book and I would start reading. So at this point in the video, feel free to read by yourself if you would prefer that, or you can also read along with me. I know sometimes it's just easier to have some things read to you. So I am going to read this, these 7 pages of text and probably give a couple hints to the class kick. So we're going to go ahead and start down here with natural resources. You walk into a room and switch on a light. Where does the electricity to power the light come from? It might come from a power plant that burns coal or natural gas, or it might come from a rooftop solar panels made with silicone, a mineral found in the sand. The smallest microbe and the largest whale both rely on materials and energy from the environment. The same is true for humans. People depend on the environment for food, clothing, and fuels to heat and light their homes. Parts of the environment that supply materials useful or necessary for the survival of living things are called natural resources. Natural resources include land, air, minerals, and fuels. The trees and water in Figure 1 are also natural resources. So, what I'm seeing from the class kick is we were supposed to give the definition of natural resources, and we just defined natural resources, right? So we have natural resources highlighted and bolded. That's going to be parts of the environment that supply materials useful or necessary for the survival of living things. Okay, so go ahead, pause the video, fill that out in your class kick. What I would do is I would take my text box and go ahead and put a text box here. And I'm probably going to make my text, not that small, smaller. And I'm going to say parts of the environment that supply materials useful or necessary for the survival of living things. So I would go ahead and put that in. And honestly, what I would do is go ahead and split my screen so that I have these on two separate boards so that I can see both at the same time. I don't think that my video will record that way, so for now I'm just going to leave it how it is. So then I would come back here and I would keep reading, keeping in mind that I'm going to include those different things and what we rely on them for. Okay, so we're going to keep reading. Natural resources include land, air, minerals, and fuels. So we can come to our class kick and we have 1, 2, 3, 4. So we can go ahead and fill those in. Again, we're going to use our text box. And we're looking at land, air, minerals, and fuel. And I'm just going to fill that in like that. So now I'm going to see what do we rely on them for. Okay, so non-renewable resources. How often do you travel in a vehicle that runs on gasoline? Do you drink soda from aluminum cans or sip water from plastic bottles? Gasoline, aluminum, and plastic are made from non-renewable resources. Non-renewable resources are natural resources that are being used up faster than they can be replaced by natural processes. So when I'm reading this, I'm taking note that non-renewable is highlighted and bolded, and then looking at that definition, right? Non-renewable resources form slowly, usually over thousands or millions of years. If they are used up faster than they form, they will run out. Non-renewable resources include fossil fuels and minerals. Okay, so at this point, I'm just going to continue to read, and you all can pay attention to this and fill it in as I read. So we just went through examples of fossil fuels, or we're about to go through examples of fossil fuels. Okay? So, fossil fuels. Fossil fuels include coal, oil, and natural gas. The fossil fuels we use today form from the decayed remains of organisms that died millions of years ago. Although fossil fuels are forming all the time, we use them much more quickly than nature replaces them. Fossil fuels form underground, as shown in figure 2. So this is our figure 2, right? Coal is mined from the ground. Oil and natural gas are drilled from the ground. Fossil fuels are used primarily as sources of energy. Many electric power plants burn coal or natural gas to heat water and make steam that powers generators. Natural gas also is used to heat homes and businesses. Gasoline, jet fuel, diesel fuel, kerosene, and other fuels are made from oil. Most plastics are also made from oil. Minerals. Have you ever added fertilizer to a plant's soil? Fertilizers contain phosphorus and potassium, two minerals that promote plant growth. The human body also needs minerals for good health, including calcium and magnesium. So those are all minerals that we just talked about: phosphorus, potassium, calcium, and magnesium. Minerals are non-living, right? So non-living, they're not living substances found in Earth's crust. People use minerals for many purposes. Gypsum, that's another mineral, is used in wallboard and cement. Silicone is important for the manufacture of computers and other electronic devices. Copper is used in electrical wiring. Uranium is a mineral, and we've already talked about this, right, with our nuclear energy. Uranium is a mineral that can be used as a source of energy in a nuclear power plant, such as the one shown in figure 3. The nuclei of uranium atoms are split apart in a reaction known as nuclear fission. Some of the energy that held the nuclei together is released as heat, which is then used to boil water and produce steam to generate electricity. Like fossil fuels, most minerals form underground by geologic processes that take millions of years. For that reason, most minerals are considered non-renewable. Some minerals, such as calcium, are plentiful. Others, such as large rubies, are rare. Again, go ahead and check what I just read. Maybe pause the video and see what you can fill in on your class kit. Renewable resources. Supplies of many natural resources are constantly renewed by natural cycles. The water cycle is an example. When liquid water evaporates, it rises into the atmosphere as water vapor. Water vapor condenses and falls back to the ground as rain or snow. Water is a renewable resource. Renewable resources, this is an important word, I hope you all know that, are natural resources that can be replenished by natural processes at least as quickly as they are used. These resources do not run out because they are replaced in a relatively short period of time. They include water, air, land, and living things. Renewable resources are replenished by natural processes. Still, they must be used wisely. If people use any resource faster than it is replaced, it becomes non-renewable. As shown in Figure 4, forests are sometimes non-renewable resources. So if we look at Figure 4, we're looking at all the trees that have been cut down for lumber because they can't grow back as fast as we're using them in some cases. Air. Did you know that plants produce almost all of the oxygen in the air we breathe? Oxygen is a product of photosynthesis. You might call that photosynthesis is a series of chemical reactions in plants that use energy from light and produce sugars. Without plants, Earth's atmosphere would not contain enough oxygen to support most forms of life. Air also contains carbon dioxide, CO2, which plants need for photosynthesis. CO2 is released into the air when dead plants and animals decay, when fossil fuels or wood are burned as a product of cellular respiration in plants and animals. Recall that cellular respiration is a series of chemical reactions that convert energy from food into a form usable by cells. Without CO2, photosynthesis would not be possible. Land. Fertile soil is an important resource. Topsoil is the upper layer of soil that contains most of the nutrients plants need. Gardeners know that topsoil can be replenished by the decay of plant material. The carbon, nitrogen, and other elements in the decomposing plants become available for the growth of new plants. Topsoil can be classified as a renewable resource. However, if it is carried away by water or wind, it can take hundreds of years to rebuild. Land resources also include wildlife and ecosystems, such as forests, grasslands, deserts, and coral reefs. Water. Can you imagine a world without water? All organisms require water to live. People need a reliable supply of fresh water for drinking, washing, and irrigating crops. People also use water to run power plants and factories. Oceans, lakes, and rivers serve as major transportation routes and recreational areas. They are important habitats for many species, including some that people depend on for food. Most of Earth's surface is covered by water, but only a small amount is fresh water that people can use, and this water must be clean before you can drink it. Fresh water is renewed through the water cycle, but the total amount of water on Earth always remains the same. Has your community ever been asked to conserve water because of a drought? A drought can cause supplies of fresh water to run short. In many large cities, water is transported from hundreds of miles away to meet the needs of residents. In some parts of the world, people travel long distances every day to get the water they need. Excuse me, sorry. Okay, again, go ahead and pause the video. Make sure you're filling in as we go. We have 2 more pages to get through. So you should be looking at Class Kick. We're about to go through inexhaustible resources, which I believe, we start looking at halfway through page 2. Okay, inexhaustible resources. An inexhaustible resource is a natural resource that will not run out no matter how much of it people use. Energy from the sun, solar energy, is inexhaustible. So is wind, which is generated by the sun's uneven heating of Earth's lower atmosphere. Another inexhaustible resource is thermal energy from within Earth. Solar energy. Without heat and light from the sun, life as it is on Earth would not be possible. So if you studied food chains, you know that energy from the sun is used by plants and other producers during photosynthesis to make food. Consumers are organisms that get energy by eating producers or other consumers. The energy and food chains always is traced back to the sun. Solar energy can be harnessed for many uses. Greenhouses trap heat. They make it possible to grow warm weather plants in cool climates. Solar cookers concentrate the sun's heat to cook food. Large solar power plants provide electricity to many homes. Solar energy also can be used to heat water for individual homes as shown in Figure 5. So we can also collect sun using solar panels so that we can use it for electricity in our homes. So some people have solar panels on their houses for that. Wind power. What do sailboats, kites, and windmills all have in common? All are powered by wind, the movement of air over Earth's surface. Wind is an inexhaustible resource produced by the uneven heating of the atmosphere by the sun. If you live in an area with frequent strong winds, you might have seen giant wind turbines. These turbines, such as ones shown in Figure 6, so these are our turbines up above, can be used to produce electricity. Geothermal energy. Another inexhaustible resource is the geothermal energy. Geothermal energy is thermal energy from within Earth. Pockets of molten rock or magma rise to the surface of some parts of Earth's crust. The magma heats the underground water and rocks. The heated water produces steam used to generate electricity. In California and other regions, geothermal energy produces electricity on a large scale, shown in Figure 7. Okay, so that is the end of the reading. You should use the PDF of this that's located in the Google Classroom assignment. It will be attached there to go through and continue to fill in this class kit. Okay, so each little box is worth 1 point, with the exception of this, which is worth 2 points. Okay. This will be worth a total of 50 points because I think there's 46 points total, and then I'll just give 4 free points just to make it a nice round number. Again, you'll have today and tomorrow to work on it. Get as much done as you can today, and then tomorrow finish it up. Once you have finished, don't forget to press turn in or submit it on Google Classroom, or mark as done. Maybe mark as done will be what's there for you all. So mark it as done so that I know to go back and grade it. As always, email me with questions. You can also comment in Google Classroom. There's like normally a little comment box on here. You can comment so that I can respond to you if you're having any problems or issues with that. So let me know how it goes, and I will see you all later.